Hey there, world. Welcome back to the lab. I hope everyone has had an exciting and productive week. My week has been crazy, having spent a lot of time learning some hard lessons. I must say, the communities of hobbyists, DIYers, and makers are absolutely amazing. I have found so much information and help online from others that share what they do. I want to thank Carbon Aeronautics, Nicholas Ream, Tom Stanton, Fabiola Clayton, and Jason from Makera. Your videos have helped me out immensely. I was hoping to have my prototype assembled and flying by this weekend, but I had a lot to learn as I worked through fabricating my own printed circuit board for my flight controller. 11 attempts later, I almost have my PCB ready to go. Let me show you how the prototype is coming along though. As you can see, all the parts have been 3D printed and the PCB fabrication is still ongoing. I should have the scaled down prototype mini Vitruvius assembled and ready to test the flight controller in the next few days. In the meantime, I'd like to spend a little bit of time giving you the background of Vitruvius. For those of you just joining us, Vitruvius is a heavy lift drone I am developing to compete in the DARPA Lift Challenge this summer. If you missed my previous video, go check it out and share it with your friends. The video talks about what the DARPA Lift Challenge is and what this project entails. Let's start with how I came up with the concept. First, I laid out the requirements that the drone must meet. The maximum weight of the aircraft is 55 pounds. The altitude of the flight is 250 feet above the ground. The distance that it will cover is 5 nautical miles. It's going to have to take off twice and land twice during this period. Once after 4 nautical miles with the payload, and then it'll fly the last nautical mile without the payload and land again. The flight duration has to be 30 minutes or less, and the goal for the payload is a 4-to-1 lift ratio, which is 220 pounds. So the total weight comes out to 270 pounds. Now that we have that, let's talk about the major systems of a drone. It's important to talk about these before going into the calculations because every component is tightly coupled to one another, meaning that there are trade-offs in every decision. A positive gain in one component can lead to devastating concerns in another component. You will see what I mean shortly. In short, a drone can be broken down into 4 systems: control system, the structural system, the propulsion system, and the power distribution system. We're not really going to talk about the control system today, but we'll definitely cover it later on in the video series. The structural system is essentially the airframe itself. The motor mounts, arms, the body, engine mounts, wing, and payload system. The airframe can be built out of various materials like aluminum, carbon fiber, titanium, or plastic. Some materials are lighter than others, and some materials are stronger than others. We need lightweight material that is strong enough to handle the amount of stresses and forces being placed on it in flight. But it also needs to be cost effective, because I do not have a 6-figure budget for this project. We can't quite make decisions here because we don't know how the airframe will be arrayed. Will we use 4 motors, 6, 8? How much thrust will each motor produce? Now would be an excellent time to talk about the propulsion system. The general convention is that an aircraft needs to produce 2 times its weight and thrust for it to maintain stable control during ascent and hover. Let's use the max weight allowed for the challenge as the aircraft weight plus the weight of the payload, which is 275 pounds. This means we will need roughly 550 pounds of thrust. Well, I started looking at various motors and their specifications. I started with T-Motor's U15 KV80 motor. Its max thrust is 36.5 kilograms, or about 80.5 pounds. That means 4 of those motors would make a little over 320 pounds of thrust. That's short of the normal convention by 230 pounds. Yikes. Now let's make matters worse and bounce over to the power distribution system. That same motor, generating 80.5 pounds of thrust, requires 8,580 watts to produce that amount of thrust. Multiply that by the 4 motors, and our drone will require 34,320 watts. Now we know that our max flight time is 30 minutes. So if we multiply our power by 0.5 and then divide by the voltage, which is 60 volts, we need a power source capable of providing 286 amp hours. Looking at some high-end lithium polymer batteries, you'll find that an 18S battery with 72 amp hours weighs a whopping 14.94 kilograms, or almost 33 pounds. And we would need 4 of them. Just the battery weight alone would be over 120 pounds. That's not going to work. So what other propulsion systems are there? Electric ductless fans, internal combustion engines, turbines, and for power, aside from batteries, we could use gasoline, diesel, or hydrogen. There are so many options out there. We need a propulsion system that is lightweight and capable of producing a large amount of thrust with minimal power. And we need a power distribution system that is also lightweight and efficient at providing the amount of power required. Now you probably understand what I meant when I said that all the components of the drone were tightly coupled. If we pick a motor that produces enough thrust but requires a significant amount of power, and we want to use batteries, we're never going to make the weight. If we use more power efficient motors, then they may not produce enough thrust to lift our payload. And whatever choices we make for propulsion and power, the airframe needs to be strong enough to lift itself and the payload, all while remaining under 55 pounds. Aside from those decisions, I think we're also going to have to overcome the normal convention of a 2-to-1 thrust-to-weight ratio by a significant margin. So what decisions did I make? You're going to have to stay tuned in to find out in a later video. You're not going to want to miss it. So make sure you subscribe so you can continue to follow along. As always, thanks for watching. If you have anything that you want to see or you have questions about, feel free to ask in the comments section. Until next time, build, learn, innovate.